Hi, this is Mr. Shumway. This video clip is to explain how to get exponential equations from a graph when you only see every second value. So it counts by 2's, so to speak. So I have a reading at 0, at 2, 4, and 6. And it looks exponential because of the curve. So we try to estimate that value right there. It's close to 2,000. Maybe we'll call it, what, 1,900? So there's 400, but there's 500 between these. So yeah, let's call it 1,900. And this one we'll call 500. So if I say 1,900 divided by 500, that gives me a value of 3.8. So it's it's about 4 times as big. Well, I've taken 2 steps from 4 to 6. And so what have I multiplied it by? This number, I've multiplied it by that number twice. If you multiply something by a number twice, that's the same as multiplying it by that number squared. So let's take the square root of 3.8, and it says that number is 1.9. Well, since I didn't read these numbers exactly, that is closer to 2. So 1.9 is close to 2, so I know there's some value times 2 raised to the x. Well, to find out what that value is, let's go ahead and plug in that 1,900. So let's say 1,900 equals this value times 2 raised to the, well, the 1,900 is going to be 6. X is going to be 6. So to solve for that starting value, I multiply by 2 to the 6th. I divide by 2 to the 6th. Because it's multiplied by 2 to the 6th, that cancels. So V equals 1,900 divided by 2 to the 6th. So 1,900 divided by 2 to the 6th tells me 26.7. No, 29.7. And since I did all of these with whole numbers, the starting value would have been 30. So the equation is this: y equals 30 times 2 raised to the x. Well, let's do another one just so we can see what's going on here a little better. Maybe here's 7,000. And here's 1,000. So what should we call it? Like 7,300 and maybe 900. So 7,300 divided by 900, that gives us a value of 8.1. Well, I multiplied by something twice and got 8.1. So something squared is 8.1. So let's find the square root of 8.1. Calculator says that's 2.85. So since I did these in whole numbers, that's going to be 3. So we know y is equal to some starting value times 3 raised to the x. And if I choose this 7,300 that we think is that some starting value times 3 raised to the 6th. So if I divide by 3 to the 6th, then I can solve for the starting value. And the value I get is 10. So the equation is y equals 10 times 3 to the x. Even if we're not very close on our 7,300, then we can still get that starting value as long as we look for the nearest whole number. And we can get that it's being tripled every time, 3 times bigger. Okay, so here's 700. So that's what, maybe 780? And here, well, that's maybe 195. Not quite 200. So let's say 780 divided by 195. I get a value of 4. And that's 2 steps. And so if it's 4 times as big, then it was multiplied by something twice when that something is 2. So I know some starting value times 2 raised to the x, multiplied by 2 twice to get 4 times bigger. Well, and then I could maybe plug in a 780, and that's some starting value times 2 raised to the 6th. Let's solve for that by getting the v all by itself, so 2 to the 6th divided by 2 to the 6th, 780 divided by 2 to the 6th. That gives me a value of 12. So I know my equation is y is 12 times 2 raised to the x. Getting twice as big every time, 12, 24, 48, 90, 96, 192. Anyways, let's try another one. Okay, so that value is fairly close to 3,000. Since we're looking for round numbers, should be okay. So here's 500. So what's that? 300? Okay, so that's 10. Well, if I multiply by something twice and it's 10 times as big, well, the square root of 10 is 3.3 something. So I used a 3. So we know y equals some starting value times 3 raised to the x. And if I choose a value of 3,000, even though that's not exact, it'll still work. Some starting value times 3 to the 6th. Solve that. Divide by 3 to the 6th. Calculator says that's 4, closer to 4 than any other number, than any other whole number. So the equation is this. Started at 4, tripled every time that it increased.